Okay, hi students. So we are going right now. Let me make sure. Yeah, we are going. So I am trying something different. So this week I will be able to use the tools from Big Blue Conference and then afterwards post this to YouTube so it will not disappear in 2 weeks just because I do this every semester. So I'm trying something different. Though I'm trying it at the very end of teaching this. Probably should have done it earlier. Okay, so I kind of jump around, just a heads up. I jump around in Lab 3. This is one of the labs. It's a little bit easier to teach in person, but I think we can get through it. So, and if this works out, this is how I'll be doing it. So you can just ignore the Big Blue Conference things. All right, so things to remember. Go ahead and get your plagiarism tutorial done pretty early, as soon as possible. It's due before the final paper, though, at the end of the semester. All right. So I'm going to read off of page 27. And let's go to Big Blue button. Alright. So here we go. Okay. I'll read some of this. Understanding the Earth's movement in space and its changing relationship with the Sun is essential for understanding atmospheric and the Earth's surface processes. The Earth's movement directly affects the intensity and duration of solar radiation, which accounts for the seasonal changes in temperature and precipitation. Seasonal climate changes directly affect vegetation, hydrology, formation and erosion, ocean currents, among other processes. The purpose of this exercise is to develop an understanding of 1, Earth rotation and the revolution, and 2, changing declination of the Sun and how this affects changes in the duration and intensity of solar radiation. Alright, so Earth rotation, sorry about this little dot right here, but rotation refers to the motion of the Earth turning on its axis. So the direction of rotation is west to east or counterclockwise as you look down on the North Pole if you have a globe around you. A solar day is defined as 1 complete rotation relative to the Sun. While the Earth's angular velocity is 360 degrees a day, or 15 degrees an hour, its speed, or linear velocity, depends on latitude. The distance around the Earth at the equator is 24,900 miles, or 40,075 kilometers. A point at the equator would move this distance each day. What is the Earth's speed at the equator, which is 0 degrees latitude? To find this is going to be a bonus point. You are going to take your miles, which is going to be, I will give you a hint, it is right here. And then you are going to divide it by how many hours there are in a day. So you'll take your miles right from right here and then divide it by how many hours are in a day, that number. Then you will do the same thing. You'll go to kilometers. It's given to you right here. And then you will divide that by how many hours there are in a day. And those are going to be 2 points. Alright, go ahead and skip this part. And then we'll read about the declination of the Sun. I'll go through here pretty quickly and then we'll go through the PowerPoint. The Earth revolves in its orbital path around the Sun on the plane of the ecliptic. The Earth's axis is inclined 23.5 or 23.5 degrees to a line perpendicular to the ecliptic, which is 66.5 degrees from the ecliptic. Remember, 23.5 degrees is your tropics. From last week we learned that, and I explained to you that throughout the semester. When you see 23.5, you can take 90 degrees and subtract 23.5 degrees, and you'll get 66.5 degrees. So the Antarctic circles start at 66.5 degrees, where our tropics right now are around. We always say it's close, but it's 23.5 degrees. So the Earth's axis is in a fixed position relative to the star, so that the North Pole, which is 90 degrees, always faces the North Star. As the Earth moves in its orbital path, the axis changes its position relative to the Sun, which you can see on page 29 at the top on figure 3.2. It's also in your PowerPoint. You'll see an illustration of this. You can also look up a YouTube video. Because of the Earth's 23.5 degree axis tilt, the direct ray of the Sun, or the latitude on the Earth where the Sun is directly overhead, so it's where the Sun is the most direct, moves between the Tropic of Cancer and the Tropic of Capricorn. The direct ray of Sun, or the declination, so declination is the direct ray of Sun, for every day of the year is shown on the analemma, which is figure 3.6 at the end of the exercise. So go ahead right now and tear out page 37 because we'll be using it throughout the class. And it's really hard to do if you don't tear it out of your manual. And you're going to have to do it anyways. Well, actually, I guess in this class you don't have to. But go ahead and do it. So, note that the direct ray of the sun is farthest north in late June, which is the summer solstice, and farthest in the late December, the winter solstice. Alright, and then the sun crosses the equator at 0 degrees, which the equator is 0 degrees, twice each year on the March and September equinoxes. So what I'm looking at is somehow missing that page. Hold on one second. And I can pull this page up really quick. Okay, so ray of sun, and we're looking at this. Now let me go ahead over here, and I can pull up. It's going to take a second. I forgot to pull this up. Sorry. If it's going to go, there it goes. There we go. Okay. Another reason I can't use Big Blue Button is some files that are too big won't load. So, okay, this looks like a lot. It is a lot, but don't worry about it. Okay, this is an analemma. This is my analemma. Alright, so, on this, we're going to look and read through page 20, or I'm going to read through the bottom of 28 really quick. And it says, as the Earth moves in its orbital axis, the axis changes its position relative to the sun. Because of the Earth's 23.5 degrees axis tilt, direct ray or sun, or the latitude on the Earth where the sun is directly overhead, moves between the Tropic of Cancer. Tropic of Cancer is at 23.5 degrees. It's about right there. And then 23 north, and then 23.5 degrees south. So what I get to do, my students to do is highlight your equator. 0 degrees latitude, remember, equator. And you can write out next to it if you need to, and then do a little arrow, and you can write N for north, or you can write northern hemisphere, and then south right here. It's important to remember that this is the southern hemisphere, and this is the northern hemisphere. So you've got 23.5 degrees right here, 23.5 degrees here, and they just went ahead and put all the way to 25 degrees, so everything can be covered. But what it's saying is, this is going to be the path of the declination of the sun. The declination of the sun, as we read on page 28, is going to be the direct ray of sun. Let me exit out of this, and we'll go back to our PowerPoint really quick. Okay. So declination of the sun. The intensity of solar radiation or insolation varies based on latitude. This is all through here. You can read about this. The Earth's tilt affects the insolation throughout the year. This is in your book. It's just saying in a different way. Earth revolves in its orbital path around the sun on the plane of the ecliptic and has a tilt of 23.5 degrees, something we just went over. Therefore, the direct or vertical rays of the sun strike different areas on the Earth as Earth's axis changes position relative to the sun. This is just explaining everything that you see on the top of page 29. These direct rays are referred to as the declination of the sun. So how I always explain it is, think about if you had a flashlight anywhere. You had a flashlight and it's just moving up and down, and you were staying in between 23.5 degrees and 23.5 degrees north and south. And so you're continuously moving, but you're moving in this weird way as the Earth's turning around. So that is what this is mapping. If you ever look on a globe, you'll see an analemma. You'll see in between 23.5 degrees and 20 north and south. You'll see just at one spot, they'll have this drawn on there. It's not artwork or anything. It's actually, there's a point to it. So it's showing where your declination is. So, strongest part of the sun, basically. So, in June, note that the direct ray of the sun is furthest north in late June. Alright, and also go ahead. I'm jumping around a lot. Sorry, I drank a lot of coffee. Go ahead. The sun is at the highest in June. That would make sense. Just to give you a heads up, we're at what latitude coordinate? 31 degrees north. So we're going to be over here somewhere. So the longest day for us is going to be in June. and it's actually it's between June the 20th and June 21st. So go ahead and put a little dot at the very top part of this analemma. You can or an X, and then write summer solstice. That's going to be your summer solstice. Then after the summer solstice occurs, the sun starts to move back down south. So go ahead and put your arrows where your sun's moving. And as your sun moves further down south, or further from us in Hattiesburg, Mississippi, your days are going to decrease in the northern hemisphere. So every day the sun moves down, you've got your days decreasing in the northern hemisphere because it's moving further away. It's moving further and further away from the top, and it is going closer towards the southern hemisphere. Alright, so the day that the sun crosses the equator and heads into the southern hemisphere is going to be called the autumn equinox, or you can call it let's just call it the autumn equinox. You can call it like March, September equinox, but autumn equinox is going to be right here. So go ahead and make a little arrow, or you can make a little X over it, and then right next to it, autumn equinox. As soon as your days have been increasing. As your days decrease in the northern hemisphere, you're going to have your days increasing in the southern hemisphere. And by days increasing, we mean hours of sunlight. Everybody understands that. So they've already been, as soon as they start heading south, the days are increasing for the southern hemisphere. But what the equinox means is once the sun's declination is in the southern hemisphere, that means that your hours of daylight are going to be more than your hours of darkness. Okay, that's what that means. Alright, so the sun keeps moving down. Your days are continuing to increase in the southern hemisphere, and they will increase until the winter solstice. The winter solstice is going to be in between December the 21st and let me undo that real quick, because it's not as far as it is. December 21st and December 22nd. Somewhere around there. Okay, you can see this. I made a little arrow hatch. Alright. Winter solstice for us. Longest day for people in Brazil down here. I'm going to put just a B. Whereas we're going to have the shortest amount of daylight up here in Hattiesburg, because the sun is the furthest, or the sun's declination, which it means its direct rays, are furthest away from us. Alright, so it's just flip-flopped. Christmas or wintertime in Brazil, that's going to be their summertime for them. Right? They're going to have long days. Whereas Christmas for us, up here, not, I shouldn't point up here, but people up here in the northern hemisphere, their days are going to be the shortest over here. But I just use Hattiesburg as an example. So that makes it so you can relate. Okay, as soon as the winter solstice happens, the sun starts moving back, let's think of the flashlight, starts moving back north. So in February, the declination of the sun is always going to be February the 20th. That makes sense. You see January, February, March, it's moving through, and that's how we know. Besides, obviously they have this, but it's showing, you can kind of follow this, January, February, March, and this will make sense in a second. Put your arrows up, and then when the sun leaves the southern hemisphere, that is the spring equinox. And the spring equinox is going to be March the 20th or March the 21st. We see that March. Alright. And then it comes back through. So that makes sense. We're just mapping the declination. We've got June right here, July. This is where the sun's declination is, August 20th. Keeps going. And make sure that you pay attention that this isn't May the 5th over here. You need to make sure that you're following the pattern, because some people would say this is May the 5th. That's not May the 5th. This is May the 25th. And since it's going this way, this is going to be June the 5th, right? And that's July the 5th. So make sure you're following that. So write all this out. Make sure you have it all filled out. And this is going to help you answer the rest of the questions. Now, I have taught this class a couple of semesters, and that means that the dates given, where you do on page 29, it says refer to the analemma figure 3.6 for the following questions. We have used the same dates for the past couple of years because it's a lot easier than having to change out. But I haven't changed them out in a minute, and we're using fall dates. So I'm going to go ahead and redo this where we are using the actual date of today, which is February the 9th. So put in February the 9th right next to today. And then 1 week from today is going to be February the 16th. Right, and then 1 month from today is going to be March the 9th. And then 6 months from today is, we've got March, April, May, June, July, August. So August the 9th. Okay, so how you'll do this, it says, refer to the analemma on figure 3.2, which you should have filled out. If you haven't, pause this, give it a second and have everything filled out. To answer the following questions. Number 1, what is the declination of the sun today? So part 1 is February the 9th. So what you will do is you will go on here. We've got September, October, November, December, January, February. So there's January, and this is February the 9th, right? That's the 5th. You see these little notches? This is going to be the 10th, so that means the 9th is right here. So let me check and make sure, and I want to use my analemma. So you can just put a piece of paper, or this is actually how I'll draw it for you to see. And let me see if I can, yeah, that's as small as it'll go. I said February the 9th. February 9th's right here. I went too low. Let me see if there. Okay, February 9th's right here. So just go all the way over, go straight across. You can use a piece of paper. You could honestly, we could probably just go up and make it straight on this line above us right here, even though it's a little bit high. But let's just say that then. So it is going to be, your declination of the sun is going to be not 14, not 16, but 15 degrees. And you have to put, if it is north or south, so make sure you put 15 degrees south. Alright, and you'll do that for every one. You'll go to the next one, which is February 16th. We've got 15 right here on this line. Go right here at the top of this black line. Let me see if my, yep, and then go right here. And you can be as detailed as you want, or you can just put that as in like 13.5 degrees. If you want to say 13.25, that's fine, but I'm not going to count off. If you said 13 degrees, I wouldn't count off either. But I just want to make sure that you know what you're doing with this. And then make sure you put 13.5 degrees south. And you'll do that for all of those. Alright. So, next step, number 2. Between what 2 dates is the declination of the sun moving north? So what this is asking is, between what 2 dates, you have to give 2 dates. That's one hint right there. Students will write down one date, and I'm thinking in my head, yeah, just have to, the answers are in the question. Between what 2 dates is the declination of the sun moving north? So all it's asking is, when is the sun moving north? Between what 2 dates? I showed you the pathway of the sun right here. You have this written. So the sun is not going to be moving north here, it's moving south. So when it starts moving north, it's going to be during the winter solstice, and then it's going to continue to move up. It's not going to stop here. It continues to move all the way up to the very top. So you can give me multiple answers. You can say, I also can kind of use the answer options from figure 3.2. So you can say the actual dates, or you could say winter solstice, and you need to make sure that you put it in order. So make sure you say winter solstice to summer solstice, not summer solstice to winter solstice, because that means it would be going backwards. For north. Yeah, that's right. Okay. And then you'll tell me between what 2 dates is the sun's declination. This is the sun's declination moving south. Alright? For number 3, you're doing the same thing. Between what 2 dates is the declination of the sun in the northern hemisphere? Oops, sorry. The northern hemisphere is here, so I need to know when the sun is in the northern hemisphere. When is it moving anywhere above here? Imagine that you just cut all this off down here, and you would tell me between what 2 dates. Make sure you put in the correct dates. When does it enter the northern hemisphere, and then when does it leave the northern hemisphere? And then, for the third one, you would say, when does it enter the southern hemisphere and when does it leave the southern hemisphere? This is the southern hemisphere, below the equator. Okay. Let's see, I have to back up and go to this other presentation. Also, since oh, never mind. Let's just make sure I've got everything covered in the lab. Okay, this is analemma. So yeah, I probably could have shown you this, but this is easier if I am in class with you. But this is showing the declination of the sun, and this you'll see this later. To determine the solar declination on any given day, we use an analemma. So what is the declination of the sun on February the 25th? And this is when I wish I could have uploaded this in. We're going here, and it's easier also to see a filled out analemma, but you would go to February 25th, and we know the path, right? It goes here. It's just a lot easier when you see everything filled out. February 25th is right here, and you just go over, and you know that it's going to be 9 degrees south or 9.5 degrees south, and then tell me the 2 dates that is. So if it's like, what are the dates, or what's the declination of the sun? And then if you're going backwards and it says, on what dates are the declination 1 degrees, you're doing the opposite. So you would start, or 1 degrees north. You start over here, and then you would draw your line backwards, which we'll see later on when we do things together. But you'll draw backwards, and you'll say September the 21st or 22nd, and March the 23rd, 24th. All right. So let's go on to this page. So let's make sure. I'm still missing pages. Okay. 29. Some of this wouldn't load because it was too big. Okay. We'll just do it this way. I'm just going to read 30 to you. You should read it. And I'm actually not going to read all of it. I'll take that back because it's just a lot. All right. Because the Earth is a sphere, 1/2 of the part of the sun, part facing the sun, is illuminated at any point in time. However, because of the position of the axis is changing relative to the sun, the amount of daylight, as opposed to darkness, changes at all positions of latitudes, except at the equator, which always has 12 hours of daylight and darkness. Figure 3.3 shows the Earth-Sun relationships on the June summer and December solstices. So when I'm saying answer options, you can say winter solstice, you can say December and June solstice. It's either way. All right, so rules for the length of day and night. 1. If the declination of the sun is in the northern hemisphere, the length of day is going to be greater for all positions in the northern hemisphere. What I just explained, I'll actually just pull this back up again because this really just iterates everything I said, but some people, it takes them a second to get it. But we'll go through the rules. If the declination of the sun is in the northern hemisphere, if it's anywhere up here, the length of day is greater than night for all positions in the northern hemisphere. And the length of night is greater than day for all positions in the southern hemisphere. 2. If the declination of the sun is in the northern hemisphere, there is a progressively longer period of daylight with a distance north until reaching the area receiving 24 hours of daylight, which is we're going to be talking about is above, it's 66.5 degrees or less, which is going to be your Arctic and your Antarctic circle. So at figure 3.3 is showing that. All right. If the declination of the sun is in the northern hemisphere, there's a progressively longer period of daylight with distance south until reaching the area receiving 24 hours of daylight. And I'll just explain that when we get to that point. So all parallels of latitude will either have greater periods of daylight or darkness for each 24-hour period, except on the equinox, when all parallels have 12 hours of day and 12 hours light. So when the sun's declination gets to the equinox, it's even hours. You have 12 hours of day and 12 hours of night at 0 degrees latitude. Okay, as the declination, or the exception is the equator. But it's going to even out here. So yeah, they have 12 hours of daylight and 12 hours of night. Number 4, and this is a typo, I think, no, it's not. As the declination of the sun moves north, everything I just said moves north from the December solstice to the June solstice, the period of daylight increases in the northern hemisphere and decreases in the southern hemisphere. So all these rules are illustrated on this analemma, and that's why it's important to have this analemma filled out. But this manual is a little out of order. It would probably helped if we'd gone over that before answering 29, but I didn't make it. So, all right, and we'll keep figure 3.3 in mind. And let's go ahead, get back to our lab manual. Alright, so number 1, it says compare the length of daylight at the Tropic of Cancer, which is latitude 23.5 degrees north, on the June and December solstices. So above June, write 20th to 21st, and then December solstice, and write the date for that. Okay, so it's saying compare the length of daylight at the Tropic of Cancer on June and December solstice. So this is like a multi-part question. Let me just go here real quick. Okay. So, tell me what the length of daylight is in June. Oh no, we're just doing Cancer. Tell me what the hours are for people who are near the Tropic of Cancer, which is 23.5 degrees north. So think about, you're not very far from that. So what are days like? What are the days like in December versus the days in June? Or what are the days like more specifically? Say, you could say in December, the days are they longer or are they shorter? And remember, you are close to the Tropic of Cancer because we're only right here. Okay? And then versus opposite. I think I said June versus wintertime. What are the days like? Hours, and by days we mean hours of sunlight. I hope that makes sense. Number 2, compare the length of daylight at the Tropic of Capricorn on the June and December solstices. We're doing the opposite. So imagine Brazil is right here. Or just use this. Or just go to 23.5 degrees. If the sun is right here, are the days longer in December or are they longer in June? Or are they shorter in June, longer in December? You answer that. And remember, because the sun's declination is the furthest in the southern hemisphere. Okay, questions 3.3 to 7 on page 31. Refer to your latitude. Our latitude is 31 degrees north. So circle north or write 31 degrees north. And then write today's date. So again, I'm going to redo this because I don't want to use September the 17th. So we're using February the 9th. Today's date is the period of daylight or darkness longer. Alright, so how you do this is, we first have to find where the sun's declination is today on February the 9th. So we know that the sun's declination is going to be right here. We've already done this. Honestly, you could literally just know the degrees by turning to page 29. Correct? Alright, so we know that it's going to be, for the 9th, it'll be about 15 degrees south. Okay, so we're right, just put a little, so you can follow along. Right here. Are the days going to be longer or shorter? So you'll put daylight longer or daylight shorter. So think about where the sun is. For where the sun is, and then think about where you are. Alright? If the sun is not in the same hemisphere as you, that means that you're going to have shorter days. Or you're going to have shorter, the daylight is going to be shorter. Right? That makes sense. Okay, tomorrow, will the length of day be longer or shorter than today? So just think about where February the 10th is. It's right here. Right? It is right here, and you have these arrows that basically give you the answer. And these words. That says, well, this gives you a hint. It says days are decreasing in the southern hemisphere, so that means, think about it. What are days doing right now for us? Are days getting longer or shorter? Okay, number 5. On what day of the year will the period of daylight be longest for Hattiesburg, Mississippi is the question. So on what day of the year will the period of daylight be longer? So what is the day of the year for us where the sun is longest? Do we have the longest days in December, or do we have the longest days in June? Just think about holidays and what you're doing in June versus December. And then how long the days are, how long you're staying, when does the sun go down in comparison. Alright? And then number 6, on what day of the year will the period of darkness be longest for Hattiesburg, Mississippi? So when is the sun, we're here, when is the sun the furthest, the declination of the sun, the furthest it can be from us? Here's Hattiesburg, Mississippi. Here's the declination of the sun. Alright? So you can write the date, you can write what describes that date, and there's 2 ways to describe that date. You can use the month, or you can use the season. And then number 7, what time of the year do you have longer periods of daylight than darkness? So this is a 2-part, it's got to be between 2 dates. So what time of the year does Hattiesburg have longer periods of daylight than darkness? Remember, you have longer periods of daylight versus darkness when the sun is in your hemisphere. And we are in the northern hemisphere. We've already answered that question in a different way on another page. But when the sun is in your hemisphere, and you have to put 2 dates. Alright? Number 9 on page 32. Alright, so which of the following latitudes, Tropic of Cancer, Equator, or Tropic of Capricorn, these are your possible answers, will have a greater period of daylight on, and then it gives you dates. Alright, so you have 3 options. You have the, let me see if I can, yeah. You got Tropic of Cancer. Oops. I'm just going to put can because I can't go very much further with that. And then you're going to have your Capricorn. Right there. Okay. Tropic of Cancer's here. Equator. Oops. Let me go back to my... Equator's right here, or Capricorn. Alright, so which of the following latitudes will have a greater period of daylight on January 21st? So I'm going to do the first one with you. We're going to find, or January the 1st, not January the 21st. We've got January the 1st, which is, this is 5th, 4th, 3rd. Well, that's the 30th, so it's right here. Okay, so the declination of the sun is right here. Alright, who is getting the most sunlight? Is it going to be Capricorn, which we're looking at right here, which is not very far? The sun's basically beaming over it. They're going to have long days, right? I just gave you the answer. Or would it be Cancer, which is up here where the sun is not anywhere near, or the equator? It's wherever it's closer to, right? So on that first one, it's going to be Capricorn. Alright, let's do... You can think of one that's kind of, there's some that students get thrown off about. Let's do, let's do March 21st. March 21st is pretty easy, actually. I guess we could do October 1st, and that would kind of say, like, well, what if? Okay, and this is the importance of following. So we got September right here. That's October 10th. This is 30 days after September, so this is October. So October is 3 degrees. This is going to be, your answer would not be Capricorn, it would be the equator. Some people, for some reason, sometimes put Capricorn. I'm not really sure why. But it's the equator. Because it's only 3 degrees away versus Capricorn, which is like 20 degrees away almost. Or 20 degrees, 20.5 degrees. Okay, so that's how you do that. Number 10, on the following date, we're going to use October 14th as the date. We always use that. On the following date, for number 10, on the following date, which is October 14th, is the length of daylight increasing or decreasing at, and then write down these latitudes, or these coordinates. Let me go to the PowerPoint, because I think it gives you, this is all the PowerPoint, this is going through everything, and I just teach it in a different way. I guess it doesn't have This is why it's important. You have to, from now on, you really do have to, you have to watch these videos, however long it takes and however terrible my voice is. So yeah, October, I guess I just give whatever I want. We always have given October 14th. So on the following date, October 14th, is the length of daylight increasing or decreasing? And then you will have, let me write it down in text. Oh, I have to write it on here somewhere. Let me full screen it real quick. Coordinates are going to be 35, and I'm going to just put D for degrees, south. Then it's going to be 90 degrees north. And then it's going to be 75 degrees south. And I don't think I have to do another one right here. Sorry. The last one will be 1 degree north. Make sure you put them in order. Make sure 1 degree is the last. Okay, just so I'm not having to go through and it's a lot quicker for me to grade. Okay, so on the following date, October 14th, got October 14th right here. So you'd say, I'd say 7, and you can say 7.5. It's really not going to matter that much. You could just say 7 degrees south. Is daylight going to be increasing or decreasing? And then, well, you just have to know that date. Know that date, and then at 35 degrees south, we go this is 24 degrees south, so we know 35 degrees south. Let me get this pen working. 35 degrees south is right here. So basically it's saying on October, are our days increasing or decreasing for people that are in 35 degrees south? Just like we did for us, right? That I put Hattiesburg up here. 35 degrees south down here. It means the days are going to be increasing. Then go to 90 degrees north. 90 degrees is going to be at the North Pole. So are your days just, if I can write it, there we go. Act like we're at 90 degrees north up here, right? Are your days going to be increasing or decreasing on October the 14th? So October 14th, days are going to be decreasing. Yeah, days are going to be decreasing. I said they were increasing, right? Yeah. Okay. Days are going to be decreasing because the sun's moving away from 90 degrees north on October 14th. We know that the sun is right here on October 14th. That means that it is in the southern hemisphere and it is not near 90 degrees north. 75 degrees south. 75 degrees south is going to be over here, right? Days are going to be doing something. Just pretty much, I mean, obviously I'm put that 35 degrees south is here and 75 degrees south is here, but you get the point. And then 1 degree north, you are going to go right here. Alright, and then you can, if you need to, think about where this is, northern hemisphere, on October the 14th. Our day's going to be, is the sun going to be moving towards it, or is it going to be moving away from it? So our day's going to be increasing, or decreasing, or increasing. Sun's moving away from it, so it's, and you answer it. Alright, page 33. Since the maximum declination of the sun is 23.5 degrees north or south, the lowest latitude to have 24 hours of daylight and darkness at some point during the year is 66.5 degrees north, which is the Arctic Circle, and latitude 66.5 degrees south, which is the Antarctic Circle. Alright, so remember how they got this is they took 90 degrees, which is our poles, and then they subtracted 23.5 degrees, and so they know that the area is going to be the other areas, or the Arctic and Antarctic is going to be 66.5 degrees. And these are areas that are getting either getting 24 hours of daylight or darkness. And let's say that, imagine, it's a lot easier to describe this in class, but imagine I have a globe and I'm pointing a flashlight at it, and because of the Earth's tilt, which I will pull this up on the PowerPoint. I think this kind of shows it on the PowerPoint. Okay. It doesn't show it the way it's, because it's not as obvious. Let me. Okay. So, I'm shining a flashlight right here. Okay. This whole area, which is 66.5 degrees down here, there's an area that's always getting sunlight 24 hours a day. Right? This area is 24 hours of sunlight, which is and that is because it's December 22nd when the sun is in the most furthest part in the southern hemisphere, right? It's at 23.5 degrees south at the lowest. So it's getting let's just say the sun's at, we'll do the math, but if the sun's like down here, this area is getting it, versus this area up here, the same number, let's say it's 66.5 degrees, because it's at 0 degrees, which is the equator. Say that is going to be 66.5 degrees and above, is going to have complete darkness. Alright. So, I'll read the bottom of 32, and it'll basically describe exactly what I explained in layman's terms, and probably explain it better. Okay, and let me just pull this back up while I'm reading. So, there are always areas on Earth that either have 24 hours of daylight or darkness, except during an equinox when all parallels have 12 hours and nights. These are the regions of high latitudes that do not rotate either into or out of the circle of illumination as the Earth turns on its axis. So it never goes out of the sun's rays. The areas on Earth receiving 24 hours of daylight or darkness can easily be determined for any day of the year by referring to the analemma. Alright, so first, for this, and go ahead and write these rules down. After I say, I'll read it, and then we'll write the rules down in a smaller version. First, step 1, you're going to find the declination of the sun for the desired date, and then subtract it from 90 degrees, which is 90 minus the declination. The resulting value represents the latitudes at and above which there is either 24 hours of daylight or darkness. For example, if the declination of the sun is 10 degrees north, you would take 90 degrees, subtract it by 10, or subtract 10 from it, and then you get 80 degrees, meaning your latitude's 80 degrees north and south, and all higher latitudes will have 24 hours of darkness. So imagine like this is 80 degrees right here. It's going to have 24 hours of darkness. Since in this case the sun is in the northern hemisphere, all areas of 80 degrees north will have 24 hours daylight on that day. All areas opposite, which would be 80 degrees south, will have no daylight at all. So it would be this one. This is what we would be thinking about. Or this is the example. So they're getting 80 degrees, and north is getting full sunlight. Down here, 80 degrees, and further down south, all the way to the South Pole, is going to be getting 24 hours of darkness. Alright, so just like I read earlier, since the maximum declination of the sun is 23.5 or south, the lowest latitude to have 24 hours of daylight of darkness is 66.5 degrees. Alright, because you can't get any further. You can't say 90 minus 24, because the declination of the sun stays between 23.5 and 23.5 north and 23.5 degrees south. Okay, so let me go back to my analemma and we'll answer these questions together. Okay, number 1, what areas will receive 24 hours of daylight, which is going to be, we're going to use today, not September 17th. So September 17th is going to be February, or the day today is obviously February 9th. I'm trying to remove all these notes from my lab manual and write it on a different thing. February 9th. Okay, so what we do is, step 1, write down this at the top. Find the date on the analemma. February 9th. Right here. I've already done it. Okay. We already know this from the beginning, but we're just going to walk through it slowly. 2, then you will find your degree. So you go over here. It's 15 degrees right. We already talked about that. 15 degrees south. So you can write it in, you can write next to it February 9th today, and then write slash, and then just put your degrees, which is going to be 15 degrees south. And then after you get your degrees, which is 15 degrees, you're going to take 90, and then you're going to subtract 15 degrees from 90. Alright? So you'll take that, and then that will give you the answer of where your declination of your sun is going to be. I guess I will give you this answer, or I'll give you like how this needs to be written out, just so you understand. Okay. So, yeah, okay, I'm just going to give it to you. Okay, so we know that 90 minus 15 is going to be 75. So, right. There we go. 75 degrees. And you can do it multiple ways. You can to 90 degrees north. Or you can, and actually put north right here too, or I can't do it now, but put north behind both degrees. So it's 75 degrees north to 90 degrees north. Or you can write 75 degrees and higher. That would also be an acceptable answer. And then some people actually put greater than 75 degrees. Greater than or equal to 75 degrees. And I'm not going to write that out, but I'll just explain that. But if you write this, you got the answer. Or you write in that format, that's correct. But if you also want to put 75 degrees or greater, or you want to put 75 degrees or higher, because it is going to be higher on this. Don't use that. The only thing that can be kind of confusing, which I would still understand, is if, because it's a higher number, but if it was in the South Pole, it would be lower, right? But it doesn't matter. Okay, so 1 month from today, we know 1 month from today is February 16th. You'll go here, you'll do the same thing, go to February 16th, find your degree. February 16th is, I'm sorry, over the place over here, find your degree. We've already done this. You'll find all this. You can actually get all the answers of this from page 29. And then you'll subtract that number from 90. And then you need to tell me, remember to put north or south. Okay? Do the same thing for June. And then the date where it's given, the date that I'm giving you is April the 10th. So you've got today, 1 month from today, which is going to be February the 16th. And then you have your June solstice, which is going to be the date given to you. And then you'll find the degree from the June solstice. And then the date I'm giving you is going to be April the 10th. And then skip the last date. So you only have to I only give you one date. On number 2, what areas will receive 24 hours of darkness? You're going to use the same dates, February 9th, and then 1 month from today. Did I say February the 16th last time? 1 month from today is March the 9th, sorry. 1 month from today, which is going to be March the 9th. Sorry, I totally screwed that up. I was looking at my notes for page 29. And then your date given is going to be April the 10th. So I hope I made that clear that I totally just screwed that up. Make sure 1 month from today is not February the 16th. That's a week from today. We're using March 9th. And then you'll have your December solstice. And a hint, you're going to look at it. Remember to have your, if it's north or south, which hemisphere it's in. And some people are going to say they're going to get tripped up because they're going to think that they can't have the same answers. But think about where your declination of your sun is and what that means for your solstices and that answer. All right, number 3. Between what 2 dates will the following positions have 24 hours of daylight? All right, North Pole. Between what 2 dates will the following positions have 24 hours of daylight? Think about the North Pole being here. It's going to be when this, I will give you a hint, it's going to be when the sun is in the northern hemisphere. I'm going to answer it that way. So it's going to be your fall to spring equinox. But that's not how you can find answers, the next 2 answers, 80 degrees north and 80 degrees, and 70 degrees north. How you'll do this is, go ahead and write to the right. Let me take a lot of this stuff off. Okay. You will look at 80 degrees north, which is going to be up here. And then you're going to say, step 1, 90 minus 80 equals 10 degrees. Sorry, I said to go up here. You're going to do step 1, which is subtract your degree, which is 80. Subtract 80 from 90 equals 10 degrees north, because they give you north over there. And then find 10 degrees on your map, 10 degrees north on your map, right here. And then you're going to make a line. Oh, sorry, that's an awful line. 10 degrees north. I went a little high, but that's okay. I'll kind of go smaller. Make sure you use like a ruler or a piece of paper. Don't be me. And then you will tell me between what two dates the sun is higher than that. So make sure you're following your arrows. So it's going to be between where this is, which we see this is important to remember like how this is written. That's April, that's April 20th. That's April 19th, and so on. It can actually be a little bit lower, I would take it. I'm pretty flexible on these because it's hard to tell these. 2, and then the sun stays up above that until, and look, and it is going to be about August, I would say August the 27th. So 80 degrees north is going to be April the 15th to August the 27th because 80 degrees is up here. And if we have where our declination of the sun, or we have our degrees for 80 degrees, you can take that and subtract it from 90, and then you can find out where that line is. Okay, so step 1, subtract the number given to you, 80 degrees. Step 1 for the next one would be 90 minus 70. It's going to be 20 degrees north. Find 20 degrees north on the map, and then tell me where the sun is above that because it's looking at north, which is above that. So where is the sun above 20 degrees north? Okay. This is probably the longest lab. Trust me, it's the longest and most difficult to teach. So it's okay. If you're not getting, write me in the discussion and I will get to you. Okay. Next page is 34. Let me pull up the PowerPoint and go to ANS real quick. All right, so altitude of the noon sun. You can read about this at the top, or you can read the top by yourself. The altitude of the noon sun, which is ANS, will depend on latitude. Because the Earth is a sphere, the sun can be directly overhead at only one latitude shown by the analemma on any day. As the Earth moves in its orbital path and the declination of the sun changes, the ANS also changes. If you know your latitude, the ANS can be determined for any day of the year. So the ANS is going to be the angle of the sun above the horizon, as that's the definition. ANS is angle of the sun above the horizon. So you can find your ANS by using this problem. Don't ignore the first one, but it says, all right, ANS at any latitude can be calculated using the following equation. ANS equals 90 minus Z. Use this one. Don't even worry about the 90 minus Z because it breaks it down. Where LP is your LS, you're going to have this. So LP is going to be your latitudinal position, and then LS is going to be the declination of the sun. So declination of the sun is going to be LS, latitudinal position, LP. ANS equals 90 minus LP plus LS, or AN equals 90 minus LP minus LS. Those are the problems. So when you have your latitudinal position and your LS in the different hemispheres, so your LP is in the northern hemisphere and your LS is in the southern hemisphere, you're going to use this problem right here. Okay? So your latitudinal position, say our latitudinal position is going to be 31 degrees north, right? Then that means that in our LS, which is the declination of the sun, is at the bottom and it's down near Brazil. That means we're going to use this problem to find our ANS. Versus if we're at 31 degrees north and the declination of the sun, it's like June, so that means the declination of the sun is pretty close to us, we would use ANS equals 90 minus LP minus LS. Right? We would subtract instead of adding on the inside. Okay. So, there's an example. I'm just going to work through 35 with you. Okay, so use your latitudinal position for questions 1 through 5. So, by your latitudinal position, it means ours in Hattiesburg, so 31 degrees north. And then today's date, which is going to be February the 9th. And then let me go ahead to our analemma real quick. Make it full screen. Alright, February the 9th, we know our degree, right? It's going to be right here, 15 degrees. Let's say February 9th. Yeah, we can just say 15 degrees. You can say higher, 15 and a half, but we're going to say 15 degrees. And then you're going to write that down in your area. So, right where the declination of the sun is today. So go over 15 degrees south. And then what is the ANS today for your latitude? And then you will use that problem I just gave you. So you know that your declination of the sun is going to be right here in February, and then we are here. So that means that our latitudinal position is not the same as our declination of the sun. Alright, so our LP and LS are in different hemispheres. And then you're going to tell me what the ANS is on what day of the year is the ANS the lowest. I'll give you a hint. It's going to either be one specific equinox or solstice. And then tell me what the ANS is on this day. So your ANS is going to be 90 minus. And then you will take that, subtract it from 90, and then get your answer. And then you'll find out where your coordinate is. And then on what day of the year is the ANS the highest? Alright, so you'll take 90 minus, and then number minus, you just plug that in. Actually, that's going to be extra credit. So let me see what else we got. We don't have anything else left. So yeah, I have got to go. I'm running late. But I think everything's good. If you have any questions, feel free, and I will just do a short Big Blue conference where we don't record it this way, and it'll be easier. So I will get back with everybody on Thursday and schedule an appointment if anybody has any problems. I hope this works because I just went through a lot of this, but it should. Have a great evening, okay?